Partho Das, Assistant Professor, JS College of Engineering, West Bengal, India. So, welcome all to my class. So, in today's class, we are going to do some school level physics. So, what is the school level physics? So, in the school level physics, we have done some pure physics part, some electrical engineering physics part, some mechanical engineering physics part. So different physics parts are there. So in this particular class we are going to see the electrical domain physics part of your previous syllabus, and we are going to recap you all those concepts, and we are going to solve different problems, and we will solve some harder problems also. So in today's class we are going to discuss about the Kirchoff's law. So as we know that Kirchhoff's has two laws. What are the laws? One is Kirchhoff's voltage law, one is Kirchhoff's current law. So regarding these two things, so what is the concept? How this concepts are applicable in different circuits, and some problems that are going to solve step by step. So let us start. Yes. So in this today's class, we are going to do those things: introduction to Kirchhoff's law, Kirchhoff's voltage law, Kirchhoff's current law, analysis of those circuits of KVL, KCL, those things. So these are the contents that I am going to cover today. Yes, introduction to Kirchhoff's law. So, introduction to Kirchhoff's law, that is, in that I am going to discuss with you, that is the history of Kirchhoff's law, introduction and types of Kirchhoff's law. Yes, history of Kirchhoff's law. Robert Kirchhoff, he was a German physicist. He actually invented two laws regarding circuit analysis, closed circuit analysis, that is the KVL, KCL, two laws, Kirchhoff's voltage law and Kirchhoff's current law, namely, after the invention of Ohm's law. So it is the generalized version of the Ohm's law. There we can different concept can be applied to solve different problems. So what is told? Describe two laws that becomes the central of electrical engineering. Yes, it is the base of electrical engineering, that is the Kirchhoff's law, voltage or maybe current law. The laws were generalized from the, as I have told, that these laws are the generalized from the of that Ohm's law. It can also be derived from Maxwell equation, but were developed period to Maxwell work. This Kirchhoff's KVL and KCL can be derived from the Maxwell equation also, but before invention of this Maxwell equations, this Kirchhoff's laws are invented. So we can say that it is a very important law for any electrical engineer, especially. So we have to know what is Kirchhoff's law. So coming to the laws, yes. In the introduction, as you can see, what and how, two terms, very significant two terms. What are the laws and how we will be benefited from this law? So these are the 2 points. What is the law? A pair of laws stating general restrictions on the current and voltage in an electric circuit. What is the restriction it has? For a particular circuits, there are some voltage, there is some current. So what is the how we can resolve that circuits? What we have to take? What is the voltage drop? What is the current flow to a node? So that things analysis of those things can be done by these two laws. So that's why it is very solved, very important. And next one is the how. The first of these states is that at any given instant, the sum of the voltage around any closed path or loop in the network is zero. That means it is telling about us the KVL. So I know you know that one. So here we are just recapping this concept, and we are going to solve different problems. And the second states that at any junction of paths or node in a network, the sum of the currents arriving at any instant is equal to the sum of the currents flowing away. So that is the KCL actually. The total incoming current is equal to the total outgoing current. So these are the things by which, these are the two laws by which we are going to analysis any kind of electrical circuits. Yes, types of Kirchoff's law. Yes, we already know from the school level physics there are two types of laws are there. One is KVL, one is KCL. KVL full form is Kirchoff's voltage law, and KCL full form is Kirchoff's current law. So first we are going to deal with this Kirchoff's voltage law. So in that, what we are going to do, introduction to KVL, this mesh analysis, and there is the exercise. So what is Kirchoff's voltage law? So first we will see that what are the points mentioned over here, and then we are going to see what is the explanation of those. So introduction to KVL. Kirchoff's voltage law is one of the two fundamental law in electrical engineering. The other is the KCL. KVL is a fundamental law as a conservation of energy in mechanics. For example, because KVL is really conservation of electrical energy. The KVL and KCL both always hold and are usually the most useful piece of information you will have about a circuit after the circuit itself. That means what is told over here? That means this KVL and KCL are the basic laws for any circuit, and from these two laws we are going to get different information regarding the circuit. So what are the, how many loops are there? What is the current flowing to a particular branch? What is the voltage across to a particular branch? What is the passing? What is the total incoming current and outgoing current to a particular node? So those things can be known from this KVL law. Yes. So now coming to the statement. So what is the statement? Kirchhoff's voltage law states that the algebraic sum of the voltages across any set of branches in a closed loop is equal to 0. So the summation of voltage, that means there is a closed loop, there is a EMF source, maybe there is some voltage drop. So all summation must be equal to 0. So that thing is the concept of Kirchhoff's voltage law. Yes. So let us take an example. So in this particular diagram, as you can see, there is a 10-volt source and 3 resistors, all are connected in series. There is a R1 resistor, there is a R2 resistor, and there is a R3 resistor. So all are connected in series. Now across R1 there is a voltage drop of VR1, and across R2 there is a voltage drop of VR2, and across R3 there is a voltage drop of VR3. Now if we apply the KVL over here, then we can say that we can write that the summation of this all the potential drops and the summation of this uh, voltage source, that is the EMF source, is equal to 0. Now you can say that if you follow my pointer, in the last line, resulting KVL equation VR1 plus VR2 plus VR3 minus 10 is equal to 0. Now the point is why there is a minus. Now just think, you are assume the current direction. See, in the diagram there is a rotation symbol. Assume the current direction. So if we think that how the loop is rotating, then it is very easily understand how why there is a minus and other component is a plus. So if we look at the R1, so in the R1 it is mentioned that it has a voltage drop of VR1, and in the left hand side there is a plus, and there is the right hand side there is a minus. So that means it is told that the current is flowing from plus to minus. For the case of VR2, again same thing it is showing. For VR3, again the same thing is showing, but in case of that voltage source, see what is shown over here. First there is a minus, then there is a plus. But for the other three cases, for the case of R1 and R2 and R3, first there is a plus, there is a minus. So that is opposite. To signify that, they have used here there is a minus. So for your simplicity, for your better understanding, for your analysis, you can consider the reverse case also. That means you can consider the minus VR1, minus VR2, minus VR3, and plus 10 is equal to 0, because at the right hand side there is a 0. So if we change the sign, so there is no effect in the equation, the result will remain same. So my point is, here we are going to see how we can write down the equation. Okay, so to write down the equation, as it is a DC circuit, so we have to find out the potential point. So looking at the which one is the higher potential or which is the lower potential, regarding that we can write down the equation. Yeah, so some points we have to remember. So those are the points. What are the points? The KVL equation is obtained by traversing a circuit loop in either direction and writing down and change the voltage of each element whose positive terminal is entered first, and writing down the negative of every element's voltage where the minus sign is first meet. See, that I have already discussed. That means when we are writing the KVL equation, very important to mention this plus and minus. Okay, so that depends upon you, but whatever you are going to take, that should be um, uh, equal for the particular problem for all loops. Okay, the loop must start and end at the same point. It does not matter where you start on the loop. Yes, it is very important. See, in case of this loop analysis or KVL, we have to consider the closed loop, otherwise we cannot apply the KVL. So for that case we have to consider some loop, some closed path through which the current is flowing, because without closed loop current cannot flow, and if current is cannot flow, then there is a no voltage equation. So we have to consider any closed loop, and in that case we have to remember always that the loop can be started from any point, before the resistance or after the resistance, or 2-3 resistance are there, so anywhere we can start, and that at the same point we have to end also. Note that a current direction must have been assumed. In this cases we are going to assume the direction of current, but in case sometimes it appears that after we have assumed some direction, we have calculated the loops, we have resolved the loops, and after that whatever some current value is we can find out, and that value is in negative. So in that case we have to think about that the current value cannot be negative. So why there is a negative? The negative signifies that the current direction is originally opposite. So that means if we assume some current direction, and after the calculation if that particular current value is negative, then we have to think of that the current value is originally opposite. Next point, the assumed current direction and polarity of the voltage across each resistance must be in the arrangement with the passive sign convention for KVL analysis to work. Yes, that thing we will better understand where we are going to solve different problems. Okay, uh, let us start. Okay, so here summation, see first what is written over the heading, summation of voltage terms may be done in either direction. So here what we have, what it is told in the KVL, that is the summation of voltages will be 0. So it can be done in the either direction, correct? That I have already told that to you, that when we are considering V1, VR1, VR2 and VR3 positive, at that time we have to consider that 10-volt source, that whatever is present over there, that is should be negative. Why should be negative? Because see, in case of R1, R2 and R3, there are the left hand side, from your point of view, if we just see the presentation, then we can say that the left hand side there is a plus, in the right hand side there is a minus. But in case of this voltage source we have opposite thing, there is a minus plus combination. So we can write down that VR1 is positive 1, VR2 is a positive 1, VR3 is a positive 1, and the 10 is a negative 1, and vice versa we can do also. So VR1 is a negative 1, VR2 is a negative 1, VR3 is a negative 1, and only V10 volt is a positive 1. So if we do this both thing, in both case we can find out the same result. So already I have told that thing here, it is depicted pictorially, so it is very easy to understand. So next case, yes, see here the direction of current flow, it is assumed negative, correct? So if we assume the direction of current is negative, see that same two types of equation may appear. Okay, and if it is appearing, then both have the same result. So why repeatedly this diagram and this equation is written? Very simple equation. The point is that to make you understand that whatever is the direction, whatever is our assumption, for all cases the result will appear same. So this is the point. So you are free to choose your loop direction, you are free to choose which one is positive, which one negative, but provided that if we are taking that from plus to minus, if the current is flowing, it is we are um, taking negative, for that particular problem we have to consider that one, not that like that for this particular branch we are taking that the plus to minus there is a negative, in next case when we consider plus to minus there is a positive. No, it cannot be applied. So whatever is your assumption, stick to your assumption for a particular problem. Next problem you can change your assumption and take the opposite one, or you can do one thing. For a particular problem you take some assumption, find out the result, and for again deal with that same problem, consider the opposite assumption and find out the result. You will find out that the both have the same result. So my point is you should free to choose what you want to do, but stick to that and you will get the same result. Mesh analysis. So mesh analysis, so let us see that it is application. So KVL is applicable to some loop, and mesh means a combination of some loop. So analysis using KVL to solve for the currents around each closed loop of the network, and hence determine the currents through and voltages across each element of the network. So in mesh analysis we have different steps. What are the steps? Assign a distinct current to each closed loop of the network. Apply KVL around each closed loop of the network, step 2. And in the step 3, solve the resulting simultaneous linear equation for the loop currents. Yes, it is an example where we are going to solve how we can solve the KVL. So here we can see that in this particular diagram two source and two loops are there, so we will assume two loop currents so that we can make two equations. So let us see how they have solved. Yes, so as per the steps we are going to solve that. The exercise 1, there is a 2 volt, one is 10 volt, one is 20 volt, there is a 10 ohm resistance, there is 20 ohm resistance, in middle there is a 40 ohm resistance. So first we have to choose some current in the loops. After that we have to make the equations using that loop current and the resistance, and then we have to resolve that to find out the branch currents. Yes, see, there are two loops current. Step 1, they have assumed two loops current, correct? Yes, determined shown by the red of this arrow mark. So these are the loop currents they have assumed, and as per that they have make that equation that we have already discussed. That is a, so see as a how many equations. So one very important thing is there, how many equations we are going to consider. So that actually depends upon how many loop you have. See, if we have two loops, as we can see in this particular diagram, so in each loop we have to consider one current value, and that is unknown. So if we have two loops, that means we have two current values and both are unknown. So to find out two unknown value, how many equations we have to find out? As per the law of mathematics, we have to find out two equations. So that means the point that you have to remember that whatever is the loop numbers, according to that find out the number of unknowns, and according to the number of unknowns we have to make the equations. So here as we have the two unknowns, so that's why we have to make two loops. So loop 1 equation is given, loop 2 equation is given, and just using the mathematical technique, different mathematical technique you can use. algebraic rules or this metric rules, whatever you want to solve, you can use to solve this problem, and after solving you can find out the result. Okay, so this is all about the KVL. Now coming to the Kirchoff's current law. Now what is Kirchoff's current law? So in the Kirchoff's current law, it is told that uh, the summation of total current incoming and outgoing to a particular node is equal to 0. So now we are going to discuss about this current law. So when you are discussing, so some points you have to remember, that is that we are going to discuss. So coming to next, so okay, introduction to KCL. So in KCL, what we have to remember, number one, Kirchoff's current law is sometimes called Kirchoff's first law or Kirchoff's junction rule. So it is sometimes an objective question. Along with Kirchhoff's voltage law, makes up to fundamental law of electrical engineering. Number two, in this lesson, it will be shown how Kirchhoff's current law describes the current flow through a junction of a circuit. Yes, that I am discussing with you. Okay, KCL helps to solve unknowns when working with electrical circuit. Yes, definitely. KCL with the addition of KVL and Ohm's law will allow the solution of complex circuit. Yes, it is. When after this KVL KCL, we have to solve difference equation, Thevenin, Norton's theorem. So there we will see that we can apply those concepts KVL and KCL to solve those theorems, and those theorems have some different concepts. So if we combine those two, then it is very easy to solve. So for different area, we have to apply different techniques. Yes, definition that will help in understanding Kirchhoff's voltage law. So what is the law? A junction in any point in a circuit where two or more circuit paths come together. That means there is a circuit. So in the next slide, you will very easy to understand. Yes, this is. So here, follow my pointer. There is a node. So with this node, different things, one resistor is connected, one source is connected, one adder is connected, one path is connected. So as you can see, there is a I1 current is going out from the node, I2, I3 and I4 current is incoming to the node, and I1 current is going out from the node. So it is told that total incoming current and total outgoing current from a particular node, its summation is equal to 0. So we can say that, see, I1 plus I2 plus I3 I4 all summation is 0. So that is the particular thing about the Kirchhoff's current law. Yes. Now the thing is that the direction. So to make you understand that, say there is a particular diagram where 5 current direction is shown. Within that, 3 are incoming, these 3, and I1, I2, I3 and 3, I4 and I4 are going out. So we have to, by mathematically, by expression, we have to express that it is going out. So we cannot write down that all are positive and all are additive, but they are additive by vectorially, but in algebraic form, what it will be. So that's why, see what I have, we have written I1 plus I2 plus I3 plus I4 plus minus of I5, correct? So this is thing that I4 we have mentioned over a minus. What is the significance of this minus? That is, it is coming, going out from the node. For that significance, we have shown over here, that is a minus. Okay, nodes analysis. So node analysis means uh, to a particular node, how much current is entering and how much current is going out from the circuit. So for that, so these are the steps we have to follow. So what are the steps? So I'm just discussing with you what are the steps to follow. Determine the number of common nodes and reference nodes within the network. So first we have to find out the nodes, common nodes and the reference node. Next, assign currents and its direction to each distinct branch of the nodes in the network. So to a particular node, some current is coming and some current is going out. So that is not that thing is not given. So we have to assume that some current is incoming, some current is going out. So that is practically or totally depends upon you So what you are going to assume, apply KCL and each of the common nodes in the network. Yes, after assumption we have to apply the KCL to each node to find out the current values, solve the resulting simultaneous linear equation for the node voltage, determine the current through and voltage across each element in the network. See, here also after finding out the result at any node, particularly some current value may appear negative. That means again the same thing. So initially we have assumed the direction, so that may be wrong, so that may be actually opposite, not wrong, actually that may be opposite. So if it is coming minus, so we have to change the direction, the symbol direction we have to change. Yes, exercise. So the same problem what we have deal with this um, KVL problem, so that same problem we have considered over here for the node analysis. Okay. Yes, so as we can see, the three currents we have assumed, there is I1 is coming, there is I2 is coming, there is I3 is going down. Okay, so these are the things. And see, we have considered this node, and at that node the middle one node. Yes, this is our problem. In this problem, this is this VA node, follow my point of this VA node we have considered, and we have seen that this is incoming, this is incoming, this is outgoing. So this plus this is equal to this one, or we can write down I1 plus I2 minus I3 is equal to 0. So we can write down I1 plus I2 is equal to I3, that equation. Now what is I3? This what is I1? I1 is the current between this voltage and this voltage, on 10 minus VA by the resistance value 10. What is the voltage over here? Yes, this is the formula. So use that formula and transfer that formula into the voltage one. And after solving this, you are very easily understand how we are going to solve this KV, KCL. So it is very those two theorems are very simple to understand. So first write down the current equation, then convert that current equation into the voltage equation, and then find out the node voltage. And after finding out the node voltage, you are very easily you can find out the whatever the particular current value. And if we know the particular branch current value, then we can find out any branch voltage. So this is all about the KCL. So this is all for today. So now we are now able to understand what is KCL, what is KVL, how we can apply those things. Okay, so this is all for today. Thank you.